Okay, so in this diagram here, we've got a system of forces, and the key word in the middle here says they're in equilibrium, okay? So when they say equilibrium, the forces are balanced. So first things first, what we're going to do is we're going to resolve these forces in a cross situation, okay? So I'm going to draw a cross, and then we're going to have all forces resolved. Now it's really important for you to note here that when you draw your cross here, we need to think of all these forces, these three forces here, as being horizontal, okay? So it's not as if this direction here is going up, okay, and then this is going horizontally. No, all the forces are horizontal. It's all happening on a single plane. So it's as if you're looking down on it, like we're looking down on it now. You're like a drone, and you're looking down, and you can see this happening all on the ground. So you've got a particle here, and there's three forces pulling at it, all horizontally. Okay, so we've got to be careful with our words. We've got to be careful here. So rather than saying this across and that up, let's just call this the X and that Y, yeah? So the X direction and the Y direction. Okay, it's a lot easier if we speak like that. So in this case here, we've got 8 newtons going in the X direction. Then with regards to the R and the S, we just need to appreciate that the R, because it's going in that sort of direction there, that's the same as going a little bit in the X and a little bit in the Y direction. Okay, so in coordinates, you'd say across the corridor up the stairs, wouldn't you? So it's a bit like that. So in terms of going across here, the component that's going across, well, because the angle is contained on this side, you use cos, yeah? Contained for cos. So it'll be R cos 45 going in the X direction, and then in the Y direction, it'll be R sine 45, okay? For the S then, because you're going in this direction, you're going across first, contain the angle there 30, so that will be S cos 30 here, okay? Because it contains that angle there, so S cos 30 component going across, and then going in the Y direction, then it'll be S sine 30, okay? Now, of course, the forces that we're told are in equilibrium. They're balanced. So in the X direction, they will be balanced. And in the Y direction, they're balanced. When we look in the X direction, these two forces combined here will have to equal 8, okay? Because they balance out. So we can say R cos 45 plus S cos 30 is equal to the 8 there, okay? And likewise then, in the Y direction, what's going in this direction going this way, it'll be R sine 45 will equal to the S sine 30 going that way. So you've got yourself two equations, okay? Now, of course, with these two equations, you can work with cos and sine in them, but ultimately we need to sort of solve them now to work out S and R, solving using simultaneous equations. When we've got sine and cos in, it can be done just as we do normally. In this case, because we've got the angles of 45, 30 degrees, we could actually type these into our calculator and they come out quite nice. So when you type in cos 45, it comes out as root 2 upon 2. And when you type in cos 30, it comes out to be root 3 upon 2. And we equal 8. So now we've got rid of the trigs here, and we've got this situation here. And we can make this even nicer if we say, like, let's just double. Let's times through by 2. So we'll double everything. So if I double this, you get root 2r. If I double this, you get root 3s. And if I double this, I get 16. So I've got myself a nice equation now for the x direction. Okay, and we'll call that equation 1. All right. Now let's obviously then look at the y direction, and then let's type that into our calculator. And sine 45 turns out to be root 2 upon 2, just like cos 45. And sine 30 becomes half. Okay, so just like then we did with the x direction, when we were dividing by 2 here, we doubled everything, and we got this nice equation here. We can double here. So when we double here, we'll get root 2r, and that will equal to just s here. When I double half, I get 1. So that will be equation 2. Now what's lovely about this is, I know that s is equal to root 2r, okay? So if I've got a value now for s, I can sub this into 1. So when I go back to equation 1 here now, I've got root 2r, okay? Well, I actually know that's equal to s, yeah? So I could actually just put s in place of it, okay? So I've got s plus root 3s equals to 16, okay? Now I've got an equation just involving s, okay? So I can solve it. I can work out what s is. Now, of course, you can put these together. You could get a calculator out. It's not going to be very nice because that's a root 3, it's a third. So what we can do is factorize out the s. That's what I do here. So s times 1 gives me that, and s times root 3 gives me that. You get 16. And then to get s, then I will do 16, take that third over. So I get then 16 divide by 1 plus root 3. So I'll type that into my calculator, and I get out 5.856 newtons. Okay, so that's what S is. And then, of course, to work out R, we just need to sub it in here. So sub back into 2. So then S will equal to 5.856. We've got that, yes. We're going to sub it in here. So I've got root 2R is equal to 5.856. So R will be 5.856 divided by root 2. So the answer, divide by root 2, and I get out 4.141 newtons.